Hello, today we're going to talk about section 2.4, more linear equations. And one thing we wanted to point out today was the point-slope form. So hopefully by the end of today, one of your objectives should be to know how to use the point-slope form and also how to use the standard form. Let's take a look at our first problem with point-slope form. As you can see, this would be a great little equation to write down with your inside your Cornell notes. And let's take a look at our first problem here. Even before I do that, I wanted to tell you that before we get started, the big thing here is knowing how to read. I know it sounds crazy, but it's the truth. You must be able to read all the questions and then also be able to answer all the questions. This section is not about the math, it's about going ahead and uh, being able to read the question and answer the question. It's not as simple as adding, subtracting, multiplying, and dividing. It is all about reading and solving and answering the question. So here, they want us to write an equation given a point and a slope. In other words, they have given that to us. Here's our point and our slope. Well, we have a special equation for that. It's called the point-slope form. So we probably need a point and a slope, and we do. We've got a point and a slope. Here's what we're going to do. We're going to first label this x1 and y1 here for these two parts of the coordinate. Obviously, this is our slope. Let's simply fill in the blanks. We're going to have our y minus our y1 equal our slope times x minus our x1 minus -5. To simplify this and make it look pretty, we're probably going to make this an addition part right here. In essence, what we have done is we have given an equation of a line, given a point and a slope. This is an equation of a line that passes with a point -5, 2, right here, and then has a slope of 3/5. That means I can go up 3 and over 5. Up 3, then over 5. And create our linear graph that way. Next one is to write an equation through the line, of the line through this point with this slope. We're probably going to use, yes, you guessed it, point slope. So again, let's go ahead and substitute our values in. Y minus our y1. Now we're going to be subtracting -1. Watch your negatives. And we're going to put our slope in, which is -3, times x minus our x1 value. And there we are. There's our equation. Now let's go ahead and graph this. Well, here's our point, 7, -1. And we need to go ahead and apply the slope of -3. A lot of you asked me, or some of you asked me yesterday, is it the same thing as -3 over 1? The answer is yes, you bet. So we can go down 3, 1, 2, 3, and then over 1 to create a negative slope. Let me clear this up here a little bit. So let's go down 3, 1, 2, 3, over 1. Down 3, over 1. We could have also gone up 3, over 1. Up 3, over 1. As long as we have as many dots as we can get and put that into a graph form. There's your equation of the line through this point with this slope using the point slope form. and then graphing it from there. Okay, let's talk about writing an equation given 2 points. And as a matter of fact, that's all we've been given is 2 points. And I really want you guys to write this down in your Cornell notes, that anytime you see 2 points, instantly find the slope. No matter what the question is asking you, find the slope. So I'm going to go ahead and find my slope here. 8 minus 2 is 6, and 5 minus 3 is 2, so that's going to simplify to 3 over 1, or 3, any way you look at it. So I found my slope. Now it says, what is the equation of the line in point-slope form? Well, remember, point-slope form is this. Where we've got our x and y value from our point and our slope to plug in. Well, if that's the deal, let's start plugging some things in. Y minus our y value, well, we can use either point. It does not matter which point you use. So let's use 3, 2. So I'm going to have y minus 2, that's my y1, equals my slope, which we know is 3. And we're going to have that x minus our x value for this point, 3. And we're done. We use this point and this slope into point slope, and that was our solution. So the big question is, what do you think you might need to write a linear equation in point slope form? That's right, a point and a slope. Aren't they clever with their little words? Let's go ahead and use this idea of point slope for our next problem here. Oh, look, we have 2 points. The first thing we do is find the slope. 7 minus 0. And then 0 minus negative 5. Be careful with your negatives. That's our slope. What point would you like to use? Negative 5, 0, or 0, 7? It does not matter. So let's go ahead and use 0, 7. So I'm going to have y minus 7 equals our slope, 7/5, times x minus our x value. Well, x minus 0 is just going to be x, so we can leave it in that form. If you do write the negative 0, that's going to be fine too. It will not count as wrong. Our next little section is going to be revisited. We've had this in the previous I'm having technical difficulties here. There we go. It's a little better. And just to say that we're going to revisit this little idea right here. Ax plus by equals c. Again, that's in standard form. Another great note for your Cornell notes. And let's take a look at this next problem here. We've seen it before. What is the equation of the line here in standard form? We're going to have to get all the x's and y's on one side. Now, this would actually be fine for just getting a regular standard form, but they want us to use integer coefficients. So I see that I've got a 4 here in the denominator, so I'm going to multiply everything by 4 to get rid of that fraction. Forgot my x up here. And there we go. It is in integer coefficients, and all the x's and y's are on one side. Let's reiterate a couple ideas about graphing this equation using intercepts. We said that if we plug in 0 for x, we find the y-intercept. If we plug in 0 for y, we find the x-intercept. Here's what that looks like. 3 times 0 plus 5y equals 15. That's going to be 5y equals 15. Divide by 5. Y is going to equal 3. Over here, 3x plus 5 times 0 equals 15. 3x equals 15. X is going to equal 5, and that's our x-intercept. and our y-intercept. Go to the graph. X is 5, y is 3, and we get to draw our handy-dandy linear function. Next, here is another example you might want to use on your Cornell notes. The last page, we have a summary of all the equations. Slope-intercept. Use this form when you know the slope and the y-intercept. Crazy name, slope-intercept. Use it when you know the slope and intercept. Point slope. Use this form when you know the slope and a point when you're giving 2 points. In the standard form, A, B, and C are all real numbers, and they want you to make sure that A and B cannot be 0 because that would give you a different type of form, not a standard form. What a great thing to put down in your Cornell notes. We'll see you guys next time.